Hello everyone. In this video we're going to be simplifying a nice cubic radical expression. We have the cube root of 5 root 2 plus 7 and we're going to evaluate and write this expression in simplest form. I'll be presenting two methods and let's start with the first method. So for my first method I'm going to do the following. I'm going to go ahead and set this expression equal to a root 2 plus b, where a and b are integers. I'm just going to assume a form like this because if I cube something like this, then I should be getting something like the radicand, which is such a weird word. Anyways, if you cube both sides, to keep a long story short, you're going to get something like this. On the left hand side, you're going to get 5 root 2 plus 7. So we're cubing both sides. And left hand side is going to give you that. And the right hand side, when you arrange the terms, obviously you're going to have some terms that have square root of 2 in them. And it's going to look like this. 2a cubed plus 3ab squared multiplied by root 2. I already factored it for you. Plus b cubed plus 6a squared b. So I didn't have to put that in parentheses, but I just wanted to show you, emphasize the two terms that we're going to compare here. The coefficient of square root of 2 is 5 on the left hand side, so this should be 5. And our constant is 7, so it should be 7. And when I say constant, I'm talking about the rational piece. Okay? So we get a system of equations from here, a cubic system. Let's go ahead and write it down. 2a cubed plus 3ab squared equals 5. b cubed plus 6a squared b equals 7. And this is a homogeneous system, which means if you replace b with something like, I don't know, at, then you're going to get a nice result. So let's go ahead and do that. Replace b with at everywhere, and let's see what we get. So 2a cubed plus 3a times a squared t squared equals 5. And then the second equation is going to give us 2 times a cubed t cubed plus 6a squared multiplied by at equals 7. Let's go ahead and simplify both of these equations, and then we're going to do something about it. So first one can be factored. Actually, this is a cubed, by the way. So if you take out a cubed, you get 2 plus 3t squared multiplied by a cubed equals 5. So maybe kind of like this. And then from the second equation, if you factor out a cubed, you get 2t cubed plus, this is at by now, not a to the t. When we take out that, we're going to get 6t from the right hand side. Make sense? Okay. And by the way, let's see. Let me double check my work. I was supposed to, okay, there's no 2 here, so I messed up. There's no 2. Therefore, there won't be any 2's here either. So this is what it's going to look like. Make sense? Cool. Now, here's what we're going to do. This is very important for homogeneous systems. We're going to divide these equations because a cubed is going to cancel out, and we're going to end up with a single variable. That's what's really nice about this. Change of variables works sometimes. And if you cross multiply, you're going to get a cubic equation from here that looks like this. 5t cubed minus 21t squared plus 30t minus 14 equals 0. And you're like, how do I solve this cubic? And I'm telling you, we've done this before. T equals 1 works. And you're like, what? Oh, come on. You didn't see that? Okay, here's what it is. Let me tell you. Don't worry about it if you haven't seen it. If you look at the coefficients, 5 plus 30 is 35. And negative 21 plus negative 14 is negative 35. So the sum of the coefficients is 0. When the sum of the coefficients is 0 in a polynomial, then t equals 1 is a solution, which is nice. And we said that, hey, b equals at, but t is 1, so this means b is equal to a. Awesome. That means we can just replace b with a in one of these equations. Doesn't matter which one. I kind of like the second one better, has fewer coefficients, looks like. At least b cubed comes with 1. So I can do the following. Let me copy the second equation from my homogeneous system. And now I'm going to replace b with a. All right, let's do it. A cubed plus 6a squared equals 7. And not, you're like thinking, how do I solve this problem, right? Oh, come on, this is fairly easy. Again, it's interesting. This comes up a lot, but anyways, I didn't plan for it, but it just came up. So a equals 1 because the sum of the coefficients is 0 again, right? Maybe I kind of planned it. So anyways, it follows again by the same rule, a equals 1. And obviously you can find the other solutions, but we're looking for the nice solution. And I believe the others are going to be complex. Anyways, a equals 1. If they're not, please let me know. They should be. If a is equal to 1 and b and a are equal, so b is also 1. But remember, at the beginning, we assume that our equation, or expression I should say, our expression is equal to something like a root 2 plus b. But then a is 1, b is 1. This becomes root 2 plus 1. So that's the answer. Yay! That was easy, right? Sort of. Okay, if you know how to solve homogeneous equations, then obviously it's a lot easier. So the cube root of this number is root 2 plus 1, which means if you cube root 2 plus 1, you get this number. Make sense? Great. Let's go ahead and talk about the second method real quick. Second method is not necessarily more elegant or shorter. It's just different, in my opinion. But I'm going to try to shorten it for you because I don't want to make this video way too long. People complain about it, and I also complain about it, you know, to myself, like, why did you make it too long? Anyways, so let's go ahead and consider, instead of evaluating one of these, because they come in conjugate pairs, let's go ahead and evaluate the sum. Let's go ahead and call this x, and then obviously what's going to follow, you already know it, right? Cube both sides. Now when you cube both sides, here's what's going to happen. You're going to a cubed, b cubed, and then plus 3ab multiplied by a plus b. So you're going to get 5 root 2 plus 7, and then 5 root 2 minus 7, and then plus 3ab. Now, if I call this a and this b, 3ab is just going to be the cube root of 50 minus 49, which is 1. And that's going to be multiplied by a plus b, but a plus b is x. So I'm just going to write it x and set it equal to x cubed. All right. 7 cancels out. 10 root 2, we get the following. X cubed minus 10 root 2 is equal to 3x. Maybe I should write it this way. It's probably better that way. X cubed minus 3x minus 10 root 2 is equal to 0. And here's what I'm going to do. I'm going to use a little trick because I'm expecting to get a nice solution. I already know the first method, hopefully. I'm going to replace x with something like, I don't know, m root 2. And then this is going to give you a nicer equation. This is what it's going to look like when you do that. You're going to get 2m cubed root 2 minus 3m root 2 minus 10 root 2 is equal to 0. Root 2 is not 0, so you can go ahead and take it out. By the way, this is not cube root of 2. It's just 2m cubed minus 3m minus 10 is equal to 0. And now we're going to get a cubic equation. Forget about this. From here, m equals 2. Why? Because it just works. Plug it in, 16 equals 16, and you'll get it. So since m equals 2, and this is my thing, from here x becomes 2 root 2. So I got the value of x. Let's go ahead and evaluate another expression, which kind of looks like this, but it's the minus version. So I'm going to take the difference of these two conjugates now and set equal to y. And then cube both sides. I'm going to cube both sides again. And this time, I should be getting something similar to this, right? Something that looks like this with the minus sign. So it's going to look like this. 5 root 2 plus 7 minus 5 root 2 minus 7. It's a minus b, or a cubed minus b cubed. Minus 3ab, 3 times 1 times a minus b, which is y equals y cubed. And this is actually an even simpler equation, y cubed plus 3y equals 14, or you can minus 14. But here it's very easy to see that y is equal to 2. Awesome. X is equal to 2 root 2 and y is equal to 2. Let's go ahead and put them together and write a system. But this time the system is like not a variable, but they're going to be numerical. So the sum of these two conjugates is x, remember, and it was 2 root 2. Their difference was y, right? And you're like, why? It is y. And this is 2. And now I do need the plus version, so I'm going to go ahead and add these two equations. Yay, the power of elimination. I get my expression 2 times. And guess what you need to do? Yes, the answer is divide both sides by 2, and you'll get the answer. Yay. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.